And welcome to lesson 8.1, day 2. Today we are going to talk about some special shortcuts to finding side lengths in certain types of right triangles, and that's our focus today is going to be on E 45, 45, 90 right triangles. So in a 45, 45, 90, the hypotenuse is the square root of 2 times as long as each of the two legs. Now, looking at this isosceles triangle that is a 45, 45, 90, when those two angles are congruent, we know these sides across from them have to also be congruent. And that goes back to what we talked about last semester with isosceles triangles. If those base angles are congruent, then we know those two legs are also going to be congruent. And then the pattern that results each time is that whatever number length these sides are, we take that value and multiply it by the square root of 2 to find our hypotenuse. Or if you're given the hypotenuse and you're trying to find one of the two legs, you divide it by the square root of 2. Always make sure you rationalize if necessary. Now, oftentimes you may like to set this up as a chart to keep yourself organized. Again, we know that the two legs across from those right angles are the same size, and they have to each be n, and then we take that number times the square root of 2, that's an n, multiply it by the square root of 2 to get the hypotenuse on the side across from our 90-degree angle. So how does this look? Okay, well, if again we are given one of the legs, we are given these legs, and we can just take that value and multiply it by the square root of 2 to find x. So if my n is 3, I just need 3 times the square root of 2 would be my hypotenuse. You try this next example. Now down below, we are given where we are actually given the hypotenuse. We are given n times the square root of 2, right? And we're looking for just one of those legs. So it's almost like working backwards, where you could say, okay, n times the square root of 2, that equals 12 right now. And I know if I have this hypotenuse, in order to find my leg, I would need to divide that hypotenuse by the square root of 2. So we divide that away. Now, we do not like to leave our answer, again, with this division by the square root of 2 in the denominator. So going back to the algebra review we talked about a few days ago, you multiply top and bottom by the square root of 2, because now the denominator is just 2, numerator is 12 times the square root of 2. Last but not least, we are able to divide 12 by 2. So each of these two legs then would be 6 times the square root of 2. In our second example, again, we are given the side across from our right angle, which is the hypotenuse. So again, to find just what each of these legs are, we would take 21, and we can solve for what n would need to be. Now this time when we divide both sides by the square root of 2, and we rationalize, we get square root of 2 times square root of 2 is 2, 21 over square root 2, or times square root 2 in the numerator. 21 and 2 are not divisible this time. So our final answer for our side lengths, 21 square root 2 over 2 for both, again, of those legs. Right, we have one more example at the bottom here for you to try. This time you are given a hypotenuse of 7, and you want to find the length of each of those two sides. All right, now a couple more examples on the back asking us to find our missing sides. Now on this first example, they are giving us the side across from this 45-degree angle, and we know that the other side is going to have to be, the other leg is going to have to be that same value, so 9. Now this side across from the right angle, the hypotenuse, we are just going to take that value of 9 and multiply it by the square root of 2 to get our hypotenuse. So x is 9, hypotenuse, which is y, 9 times the square root of 2. Now in this example, I don't know why the 45 did not print, but there were 45-degree angles here. on my notes. And what's happening is, again, we know that these two have to be the same size. These are our side lengths n. And to find this hypotenuse, we need to take that value and multiply it by the square root of 2. Well, here's the problem. When we take 4 square root 2 and multiply it by the square root of 2, we this time we'll need to simplify. Square root of 2 times square root of 2 is just 2. 4 times 2 is 8. So again, these side lengths, j and the other one, are 4 square root 2, and then that hypotenuse ended up being 8. Another example with number 6, we are starting this time with that hypotenuse, and we want to find our missing legs, right, which are going to be the same size. So similar to how we were doing it on the front page, if we set n square root 2 equal to our hypotenuse value, we can divide both sides by the square root of 2 to get what each side is. Now on this one, again, we will need to end up rationalizing because we don't love that square root of 2 in the bottom, and the 3 and the 2 were not divisible, so that didn't help us at all when we looked at those. So again, multiply top and bottom by the square root of 2. Denominator is now just 2. Square root of 3 times the square root of 2 is the square root of 6. 5 and 2 are not divisible, so each of these, best we can write them simplified. 5 square root 6 over 2. And again, those values will then be the side lengths for both of those legs. In this example, we are given another hypotenuse that is an odd number. Again, this time set these two equal to each other. Divide by that square root of 2. We end up having to rationalize square root of 2 times square root of 2. So 9 square root 2 over 2 ends up being our value of n. So again, both of those legs, after dividing by square root of 2, equal 9 square root 2 over 2. 2 final examples for you to try. This time you are given one of the legs. And on this one, you again are given hypotenuse. My apologies that did not print. Thanks everyone for watching. We will work more with these in class.